we're not going to be asking you to assess the resolution. Okay? That's just purely the contrast stability. So you now know you're going to get the resolution testable pattern as an image that looks like cylinder one. Okay? Don't think, oh, I must assess the resolution. We may ask you, what else can you assess with this test tool? And obviously we would expect you to come back and say, oh, you can assess resolutions to the resolution testable pattern in the middle, but we're not going to ask you to physically assess it. We're just interested in the number of discs that you can evaluate. So for this particular image, what I would expect you to do is start by actually providing an assessment of the darker rectangle. Okay? So you can see that it's nice and straight. There isn't any distortion to the beam. So we know that the tube hasn't been angled. Okay? Because obviously when we start angling the tube, we get the Star Wars effect, and we get distorted edges. I would then expect you to go through and actually state the measurement for each one of these borders. So you might come back to me and say, right, Kevin, I note that collimator S1 is actually beyond the rectangular area by 5 millimetres. Likewise, S2 is beyond by 1.1, S3 is beyond by 2.9, and S4 is beyond by 4.5. This is showing me that my collimated field is actually a lot larger than what I expected. Okay?
You're going to have them values on
The values will be on the images for you, yeah. Obviously, we're not going to have the number of discs that are on the least test tool or pixel purpose, you have to count that. And obviously, the same with the resolution test tool pattern. We're not going to have, oh, you should be able to see 7. We're going to have to count those and physically go through and count them. But for this particular one, you will have measurements. So those measurements will be there. Now, they're either going to be grossly over the rectangular area, or they're going to be grossly under the rectangular area, because I didn't actually collimate these borders when I took these images. I wanted to make sure that you had something that you can tell us about, okay? The next thing to consider is, well, are these measurements within limits? Are they? You're all looking at me blankly. And this highlights a really important concept in relation to the Bible. Know your tolerance values. So for like the contrast detectability, it's plus or minus 2 discs. Likewise with the resolution, from an RView point of view, it's plus or minus 2 line pairs. The collimator and beam alignment test tool, actually the measurements here is plus or minus 1 centimetre. So you looked at this image, is it within limits or not? Yeah. So I want you to clearly say to me, it's outside the border, I know I'm getting a larger radiation field than I expect, but it's actually within limits for this particular test tool. And you'd have to state what that tolerance value is. Okay? So that's why it's important to know. The next thing to do, and again, if you get this, please don't forget to do this, because a lot of students did last year, is to assess the ball bearings. Now this is the only test tool whereby you can magnify your image. So the images are going to be on an iPad. So please, don't be frightened to magnify this image, because you want to see the relationship between these ball bearings. Now if the ball bearings are overlapping, basically the beam is within half a degree of alignment. Because remember, this beam alignment test tool has 2 ball bearings that are effectively perpendicular to one another. Okay, you want them to line up. But in addition to telling me how far, and I'll say the others in a moment in relation to those 2 discs that you can see, 2 circles you can see in the middle. I'd also want you to describe their relationship, and we describe that as a compass. So are they north? Are they south? Southeast? Southwest? Now if you look at this particular issue here, they're north, aren't they? So they're touching, but they're north. So we now know that the ball bearings are in a northerly direction, which normally, if the X-ray tube was in this direction, collimators here, test tool out in that direction, it's normally meaning that your X-ray tube is going away from you, or the X-ray beam, sorry, the perpendicularity of the beam is going away, because the top ball bearing has been pushed, where the bottom ball bearing is still sitting on the crosshair of the collimator test tool. Okay? So you'd have to say that these ball bearings are in a northerly direction, but they're within half a degree of perpendicularity because they are overlapping. your bottom one is on the crosshair. The top
Of
one, the lighter
perpendicularity.
version, is basically the one that's furthest away from the chronometer test tool. And it's normally a little bit larger, but it's in a northerly direction. It's telling you your beam is actually going directly away from you as you're standing there.
Doesn't that have to be a calculation?
Half degree of perpendicularity. So it's within half a degree of being perpendicular. If there's a gap between these ball bearings and they're within the first circle, they're within 1.5 degrees of perpendicularity, and then it moves to 3 degrees in the second circle. You usually tend to get a little bit concerned when the ball bearing is on the edge of the first circle. So at that point, when it's literally on the borders of 1.5 degrees, that's when we would usually inform our medical physics expert that we think our beam is no longer perpendicular, or within the realms of being perpendicularly susceptible. So that's your limits. You've got to be literally within that first circle before you get concerned. And likewise, we'll be doing similar things with the least test tool object, or we're doing similar with resolution. So the least test tool, we want you to assess the overall image visibility. So is the image actually physically distorted? How many large circular discs can you see? So how many of the low contrast discs can you see actually on the test tool? How many dots can you see? The high contrast dots, and you must state which dot, what the dots are, what the discs are. And then how you then effectively use your grayscale. Now usually from a quantitative point of view in department, you just count the number of white grayscale discs that you can see. If you're going to measure them properly, you should be doing either a region of interest analysis or printing it out using a photophotometer if you're doing it properly. But usually we just compare it and assess it visually by just counting the number of white discs. So again, if you look at how to the data interpretation page, it will take you through how to interpret these three images. And that's what we're expecting you to do, is to come back and tell us. So for things like resolution, we might ask you, well, which, you've got a fine and broad focus image, which one would you expect to have better resolution and why? We'll then ask you to demonstrate how you count the number of line pairs that you can see, and obviously what is a line pair, how you can effectively resolve a line pair, and then thinking about other things that you can actually measure using your focus spot test tool. So that's going to be things like the actual and nominal focus spot, and you can also estimate the target angle too from geometry. But we're not going to ask you to say how you would do that, you just need to be aware. Certainly, from that point of view, if the examiner asked you what else would you measure, and you went, we'd probably turn around and say, well, they're not actually on the data table that's sitting in front of you. So, for instance, with the resolution, we have to give you a data table if we want you to convey what the line pairs per millimetre are. Okay, so if you see 5, let's say it's 1 millimetre, it's 1 line pair per millimetre. We want you to convey that information. Okay? So the next image that we're going to show you is a monitor test tool. Now I've had a couple of emails about this and a couple of people come to ask me. Now we're not going to ask you to get any numbers from this test tool. What we want you to do is take us through step by step how you will evaluate the test tool. What should you see and when should you see it? Okay? And if you look at the pages on Moodle, they actually have pink boxes. I chose that colour pink on purpose because it sort of grabs your eye. Okay? It's very similar to sort of Emily's scarf, pink on Emily's scarf. Okay? Now those boxes are sort of telling you what you need to look at. Okay? They're not telling you how you assess it because most of these test tools are actually assessed electronically. Okay? So this is what we call an SMPTE, a Society of Motion and Picture Television Engineers. The AAPM is the American Association of Physicists in Medicine. They're both monitor test tools and you can use them in very similar ways. Now, if you look at it, it's sort of one of those images that you think is either a magic tile or makes you feel a bit sick because of these sort of lines that you can see on the outskirts. But what you're doing is you want to ensure that your image has no distortion. So what is the overall image visibility? Is it acceptable? Well, I'm hoping when you're looking at these on the iPads, they will be, because these are just literally screen captures. So the test tools that you're going to see from the monitors are screen captures from actually medical monitors. So just So where would you start in relation to this? Well, again, assessment of general appearance. So does the image look nice and square? It's not distorted. Okay? You're then going to check your borders, just to make sure there isn't any distortion. And is the test tool centered to the display? Okay? Next thing is to look at your luminance patches, okay? So your luminance patches are effectively what you're seeing around here. Remember that there are two 50% patches either side here. Okay, so you hear some people when they're going through these with you, they'll say, oh, you can see, you should be able to see 11 luminance patches or 12 luminance patches. Well, you've got to remember that two of them are exactly the same. Okay? So it starts at 0 and it works its way around, all the way around to 100. Can you see these two patches here?
This is the white one.
One's got a square inside, but this one's got a square inside too. Brody probably has to see it, turn it around. You see there's two patches, there's one there, and there's one there. One's got, you can see a square, the other one you can just about see it. Well, what you'd normally do is you'd normally change the contrast and brightness on your monitor until you see both of those square patches. Okay, that tells you that you've got the level of contrast and brightness right in relation to this test tool. You then have to indicate basically what we call the 5% and the 95% patches, and that they are effectively those squares I was telling you about a moment ago, how you know you've got your level of contrast and brightness right. So this darker square inside the white is your 95% patch. This lighter square inside the dark is your 5% patch. You should be able to see both of those, and it tells you effectively you've got the right contrast and brightness for this particular monitor. Okay? You're then going to have to identify the low modulation line pairs. And I think someone asked me a question about this. We're not going to ask you to count them, but where are they? Well, they're these lines that you can see up here, the ones you can't really see very well. And that's the whole reason. You shouldn't really be able to see them very well, okay? So they're going to be your low modulation line pairs, okay? And there are 6 of them, okay, in each corner. And then there's 6 in the middle too. You then have to identify the high contrast bars, and they're the 6 here, 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 and here. Okay? And you should be able to say, well, I can see 3, I can see 3, so I can see 3 horizontal and 3 vertical, so I can see 6 of them. Same here, same here, same here. And you should be able to sort of, for this, you can say, well, I know they're there, I should be able to see 3 horizontal, 3 vertical, but usually you wouldn't see these if you've got the contrast and brightness. Just remember there's 6 of them centrally and 6 in each corner. And they're the steps that we want you to take us through. The only difference with the AAPM test tool is you will have patches, luminance patches, okay? However, they have what's called CX resolution resolution patterns in the middle, and they actually look like a C with an X inside. Okay? And actually, if you look at them properly, you'll notice the X is actually squares. Okay? And that's how they look. Now, the way you would assess these is you want to see these individual squares that make up the X. Okay? And you would count the number of the CX patterns that you can see. Once they become blurred, you stop. Okay? But nearly everything else is very similar to the SMPTE. You do assessment of general appearance. Alright? The borders is test tool centered. Okay? Can you see your luminance patches? Count the number of resolution patterns that you can see. Identify the low modulation, where are they, how many there should be. Identify the high modulation and where they should be. Now you probably will note on the AAPM, or certainly some models of the AAPM, you only have 4 low modulation line pairs. So you only have 4, and then you only have 4 high contrast bars. Okay, and that's really the difference, but you still look for them. And then in the same place, centrally and in each corner. And then the last question is we're going to give you some data. And it's a data booklet. And that data can be from any one of the tests, effectively, that we have undertaken.